Okay, so if we look at the line M, we've got the equation y equals minus 2/5 x plus 3. What that means is we can say straight away that the gradient is going to be equal to minus 2/5. Now, part A, it tells us that there's another line which goes through A, which has got the coordinates 3, 4, and it's parallel to the line M. Now, because it's parallel, we know that the gradient will also be equal to minus 2/5. So to find the equation of the line, we just do y minus 4 equals minus 2/5 of x minus 3. We want it in the form y equals mx plus c, so really we're going to have to multiply out the right hand side and add 4. So y equals minus 2/5 x plus, and that's going to be 6 over 5, and then plus 4. And so that's y equals minus 2/5 of x plus 6 over 5 plus, and 4 of course is just 20 over 5. So we end up with minus 2/5 of x plus 26 over 5. And that's the answer to part A. Minus 2/5 of x plus 5 1/5. Now, part B. Find the equation of a straight line which passes through A and is perpendicular to M. So not parallel to M this time, but perpendicular. So if it's perpendicular, so line is perpendicular, so the new M, and I'll call it MP, it's going to be, its value is going to be such that if we multiply it by minus 2/5, we should get the answer minus 1. In other words, it's the negative reciprocal of the M that we had in part A. So it's going to be 5 over 2. And it also goes through A. So it also goes through the point 3, 4. So we do the same as before, so we're going to have y minus 4 equals, this time the gradient's 5 over 2, lots of x minus 3. And if we want it in the same form as the gradient before, we're going to have to multiply out the bracket and add on 4 to both sides. So y equals 5 over 2x minus, what's that, 15 over 2 plus 4, which means that we end up with y equals 5 over 2x minus 15 over 2 plus 8 over 2 gives us minus 7 over 2. And that's the equation of the line in part B.